Hello, welcome to a short linear algebra video. In this one, we are going to be talking about ranks. And so to figure out what a rank of a matrix is, we first need to figure out the definition of what a rank is. So the rank of a matrix, we'll just call it A, and this is how you denote rank, just by saying rank of A, or in parentheses. So the rank of a matrix A is the number of non-zero rows in the matrix. And then another thing to point out would be that the matrix is in row reduced echelon form, which can be shortened as RREF. And so that's pretty much it on what a rank is. And so we're just going to go ahead and do these two quick examples. So for the first one, when you put this matrix in row reduced echelon form, you'll get 1 0 0 0 1 0 0 0 1. And so we're looking for the number of non-zero rows. And so we have 1, 2, 3. So the rank for this matrix would equal to 3. Another thing that we should know is what a pivot is. And so these leading ones are all what is called a pivot. And so a pivot is basically a leading one, such that all the rows following below it are zeros. So as you can see, for the first pivot, we have the pivot on the top left, and then everything below are zeros. And then for the second one, we have all of them below zeros. And then for the last one, well, it's the last row, so it just everything on the left has to be 0. And so yeah, another thing that we can point out is that the number of pivots is equal to the rank of the matrix. So they pretty much go hand in hand. So if you find the number of pivots, you find your rank of the matrix. And so yeah, that's pretty much it. So let's go ahead and do this second example. Not many of you may see it right away, but the third row is actually a combination of the first two. Specifically, it is the second row, the second row plus twice the first row. And so when we put this in row reduced echelon form, we will have 1 0 0 0 1 0 and then 1.5 negative 3 0. And so again, we have to look for our pivots. And so we have the one on the top left and then the one in the middle. So our pivots, or number of pivots, is 2. So that means our rank for this matrix is also 2. And this pretty much makes sense because, a rank is the number of non-zero rows. So right here we have a non-zero row in the first one and the second one. And then our pivots is just a leading one such that all the rows below it are zeros. So that's all we really care about. Again, all the rows under the pivot are zeros, as you can see on the first column and in the second column. We don't really care about what's to the right of them, because it can be all zeros. It can not necessarily has to be all zeros. In this example, we have a 1.5 and a negative 3. So yeah, that's pretty much it for this short video. Thank you for watching, and I'll see you in the next one.